This is OPI Overview Part 2. Let's take a look at the PowerOpI architecture. First, the schedule, pink blocks, Microsoft project. Structured as MS Project Gantt for each program element, with a master rollup project for linking the element Gants. The rollup exports an Excel table of task states and task information. Next, visualization, the green block, is driven by the table exported by Microsoft Project, uses Visio to illustrate the schedule. There's a training module that will describe use of project, how to export tasks, how to connect that into Excel, and how to use it to make Visio illustrations. Then tables, yellow at left using Excel, describe high-level product structure and program structure, including allocation and use, product structure, element data, and so forth. In the center, database joins combine high-level data in the tables to automatically create the equivalent of a big spreadsheet, but with detailed relationships beyond the imagination of a manually created big spreadsheet. The project exported dates table can also be used to join with the others to connect the plans to program dates. At right, reports represent plans at all levels, are driven from query results. There's a list at the right, plans by organization, process, metric, and many more. You design these reports so that organizations on the project can use them to initiate and control their work quantitatively. So schedule changes ripple automatically through build plans and into financial views. Material plans ripple automatically into financial views, all supporting the logic of sequence drives logistics drives budget. All levels of the project remain in sync, so organizational operation can also be kept in sync at a detailed quantitative level. Standalone, PowerOpI achieves full power. It can also flow into MS Power BI tools as a table or database access, increasing the capabilities of both. I should mention before we go too much farther that I have a website describing some of the capabilities in these training presentations to be posted on this site, and that there's VBA code provided on the website for Excel, Project, and Visio to perform actions described in these presentations. Here's the linkage at the core of PowerOpI. Tables are in Excel. They're read into the database, which can be Access or SQL Server, where they participate in queries that join them. The query result can be saved in the database as a table, or it can be read back into Excel, where it can drive a pivot table or can create a table in Excel. Refreshing the pivot table initiates all of that sequence, reading the linked Excel tables into the database system, using them in queries that join them, providing the query result to drive Excel pivot tables, and driving the pivot tables to select, order, and summarize the result. We're using Excel structured tables with structured references. Structured tables have been nicely implemented in Excel with a nice functional user interface, adding, sorting, finding rows and columns. Using structured tables is part of making Excel find the data rather than you setting up all the cell interconnections of a spreadsheet. Microsoft hasn't provided native support to use structured tables from an external database system, but I'll show you a small bit of code in the Tables and Queries module that makes them available. Excel structured tables support structured references. These are calculations based on fields and rows rather than on cell location. More of making data be independent of physical cell address, more like a database. We use structured references to create calculated cell values and to create structured keys. The structured keys allow us to calculate cell values using data from this or foreign tables. Other structured keys are what the database uses to join tables in queries. So once structure is set up, you can control join structures from Excel. So what are the joins shown in the database in the last figure? Okay, big spreadsheets designed manually by program managers are limited by the PM's ability to envision and then structure the spreadsheet and then to build views from it. It's extremely unlikely that all relationships and views needed will be known when the big spreadsheet is constructed. It's also extremely unlikely that a PM can humanly structure the big spreadsheet to accommodate all the views that could be wanted. Organizations are just used to these limitations and eventually stop asking for views. That limits visibility into the plans, which ultimately limits manageability. So the joins create big spreadsheet automatically, with all the complexity required to support many views. They also update automatically, so plan changes automatically change existing views. The table contents are focused on key program aspects as noted before. The net is we achieve leverage and automation. Looking at the block diagram, it shows a query containing several joins. The joins are the three boxes to the right. The boxes just to the left of them, center column, are the structured tables from Excel. The tables are joined one at a time into the evolving query result. First, the allocation table is exploded to elements using the BOM table, resulting in a list of elements to be budgeted, built, and so forth. Next, the MS Project Dates export is pulled into Excel for some calculations, and that is joined with the previous result, associating dates with allocated elements to be budgeted and built. Then element data is joined to that result, adding supplier, distributor, vendor part number, lead time, cost, etc. to each element. The result is an automatically created big spreadsheet of costed, scheduled, allocated materials to acquire, build, budget, and so forth. That automatic big spreadsheet can be read into Excel to drive many pivot tables or figures, selecting, ordering, subtotaling among the fields to provide views that illustrate plans at all levels. This has proven to be a very powerful scheme and very flexible. In the projects I've used this for, I've not come close to design limits. This is as extensible as Excel multiplied by SQL. PowerOpI is implemented by linking tables from one tool into another. This figure shows the architecture for that. Looks scary, but there are 5 principal paths through it that we'll explore. It shows implementation among the tools of the core Interconnect block diagram shown 2 slides ago. It shows tools, Excel in green, Access in red, Power BI in yellow, Microsoft's product colors, and shows paths among the tools. In a training module, I'll describe 5 main paths. 2 or 3 do 99% of all the work. In the training module, I'll show you how to implement all 5 of the main paths. You'll be able to do any others from what you learn there. Here's a path example. Structured tables are held in Excel, dark green block at left. The tables are read into Access, red at center, or SQL Server, black, where queries do the joins. The query result is brought back to Excel via an Excel data connection, dark green, or Power Query, also dark green. In Excel, the query result may drive a pivot, dark green at right, or Power Pivot in yellow. All of that happens automatically when you refresh the pivot. Here's a similar path. Data is held in an external Excel file. For example, the Microsoft Project Task Data Export file, light green at left. That data is read into Excel via an Excel data connection, or via Power Query, where it's saved as a structured table, dark green at left, for further calculation, such as fiscal calendar dates, pay dates, lead time effects. That table can later follow the path previously described, joined with other tables by the database, and return to Excel to drive a pivot. That's actually most of the work. There are some options: Excel data connection versus Power Query, or Access or SQL Server, or external SQL versus Power BI data model and DAX. These are discussed in the Tables and Queries module. Note that PowerOpI plugs seamlessly into Power BI either in Excel or desktop versions. Here's a reference on requirements and deployment. Detail will be covered in a later training module, but here's a quick summary of the sections. On requirements, Microsoft Tools, Office 365 or Office Desktop, Project, Visio Pro. Office includes Access. Optionally, you can use SQL Server, and many projects will fit in the Express version, which is free. Full function is achieved obviously using the tools on a native Windows platform. You can also achieve full function using a Windows VM on Mac OS or on Linux. I've listed several VM packages for the various environments. You can also achieve full function using a shared server. Server could be native Windows, Mac, or Linux OS. The tools on the shared server, of course, would be native on Windows, or you can put a VM up on Mac or Linux. You access the tools on the shared server using RDP Remote Desktop Client, and I've listed a bunch of those clients there. You only need a license for Office and the other tools on the shared server, not for each client. You can get a subset of the function using the Office Tools version available on Mac OS. Project Visio aren't on Mac, and I can't support a database native to Mac yet, but Excel on Mac OS can read from a shared server or from a desktop server that's hosting the PowerOpI tools. It can read the database query result, it can adjust the filters, restructure the pivot. It can't refresh and update the query on the shared server, but most times it doesn't have to if you keep the PowerOpI source files up there up to date. And then finally, I can't support cloud tools yet, databases, Smartsheet, or Google tools, but watch Google BigQuery and we'll see where that goes. This is an agenda used in a consulting workshop. You could use it to direct your viewing flow through the YouTube material as I get it onto this channel. Look at the presentation column. First is this overview. Next, how to set up structured tables and database queries. Then how to link the tools to create working paths through them. How to get schedule data and use it in Excel and in Visio, adding value to dates from the schedule, BOM table, structure of product elements to be allocated, normalization, organizing data for queries and pivot tables, how to connect SQL Server into the working paths among the tools, deployment requirements and configurations, and aligning hardware and software element development to create systems and schedule optimization. This presentation that we're looking at right now is the overview. The others will be covered in other provided training modules. Consulting sessions include template software as well. At the core of PowerOpI are Excel structured tables joined using SQL. That sounds a lot like Microsoft Power BI, Excel structured tables with relationships, import, and DAX, and for sure there are analogies. But PowerOpI started down the path before Power BI was available and uses available function, user interfaces, and APIs of Excel, Project, Visio, and SQL. Most of the core principles of PowerOpI were developed on Excel, Project, and Visio with Access SQL. Structured tables were introduced by Microsoft later and added to PowerOpI, and SQL Server was a later addition. These have proven continuously to be a very powerful and flexible combination for problems addressed by PowerOpI. PowerOpI was focused from the beginning on managing volumes of data for interactive operational inward planning, execution, and reporting across a distributed and cross-functional team, implementable by users with Excel capability and little or no IT support. I see the focus and strength of Power BI as decision support by analysis and visualization of large external data sets, static by comparison to operational data. Microsoft has developed powerful tools for data mining and display of underlying physics and conclusions embedded in large data sets, making these tools available in Excel and Power BI Desktop to support self-service business intelligence. The capabilities of PowerOpI are superior to handle swiftly changing data and scheduling for planning and execution, supporting distributed cross-functional organizations, and for displaying operational processes and progress. Then on top of that, PowerOpI and Power BI fit together seamlessly, so operational data from PowerOpI can participate with Power BI analysis of all sorts of data sets to support business decisions. Similarly, Power BI can be used for reporting some aspects of PowerOpI operational data, and Power BI data analysis could influence operational planning. So integration adds power to both PowerOpI and Power BI. This concludes the OPI overview sequence. OPI discussion continues in OPI Structure Part 1, Structured Tables. More video sequence on this channel will cover use with MS Project Gantt plans, building images from Microsoft Project using MS Visio, handling of dates, BOM table structure, data normalization for joins and pivots, use with SQL Server, common table structures, system development considerations, schedule optimization, and OPI deployment configurations.